Welcome to video number 1 of Data Science Dojo's tutorial on Introduction to Text Analytics with R. I am your host, Dave Langer. As this is the first video in this series, let's start with a quick set of overview slides. So as this is the first video in the series, I figure a brief introduction about myself is in order. So as I mentioned, my name is Dave Langer. Currently, I am the VP of Data Science at Data Science Dojo. I also happen to be one of the lead instructors teaching our many boot camps in various places around the world. I have a background in technology. I've been in the business for more than 20 years, and in that time I've held various roles. I've been a software engineer, I've been an architect, I've been a manager, but most importantly, I've been a data professional. So I have an extensive background in business intelligence, in data warehousing, and analytics, both traditional analytics, descriptive analytics, as well as predictive. My last job before joining Data Science Dojo was as a senior director of BI and analytics at Microsoft. At my last job, I had a team of technical program managers, and we owned all of the data platforms that ran Microsoft's $10 billion plus supply chain operation. That included everything from BI to data warehousing to analytics, anything cubes, OLAP, all the way up to R and Spark running on a Hadoop cluster in the cloud, anything and everything in between. But probably most germane to this video series is that text analytics is one of my passions. I firmly believe that text analytics is one of the most useful tools to have in a data scientist's tool belt, or for that matter, any data professional who's interested in doing some advanced analytics in their daily work. Text analytics is a useful skill, and we'll see that as we go through in this video series. So I joined Data Science Dojo to realize the company's vision. The mission statement of Data Science Dojo is data science for everyone. We really do believe that. We believe that you do not need a PhD in statistics, you do not need a PhD in machine learning to learn data science tools and techniques and apply them in your daily work and derive business value. We absolutely believe that. And this video series is proof positive of that. By the end of this video series, you'll have a really firm grounding in the basics of text analytics, and you can apply those skills to your daily work and derive business value. Okay. Since this is the first video, let's do a few housekeeping things. First up, there is going to be a GitHub repository for this tutorial. You will be able to get all of the code that you see demonstrated throughout this video series from this GitHub repo, and here's the URL for it. Next up, if you like what we're doing, in this video series, if you like what we're doing on some of the other things that we do on our YouTube channel, please follow us on social media. We actually provide a wealth of content, not only our own, but also hand-curated goodness of data science from a variety of sources across the internet. And we have a presence on all of the social media channels that you would expect. So if Facebook is your choice, you can follow us there. You can follow us on Twitter or LinkedIn or Instagram, Google+, you name it. We're on all of those platforms. In particular, if you like what we're doing here in terms of tutorials, we have more content on our YouTube channel. So if you like, please subscribe to the YouTube channel and you'll get not only the stuff that I'm doing in this particular video series, but you'll get updated when we produce more content and more tutorials as well. And lastly, don't forget about our 5-day bootcamp. If you like what you see here, if you like how I teach, if you like the kind of information that you get, the kind of skills that you build, we do teach a 5-day intensive bootcamp at Data Science Dojo. And of course, you can find more about that at datasciencedojo.com. Okay. Another thing I like to do in my video tutorials, as well as my talks that I give, which by the way are recorded on our YouTube channel, is to do some expectation setting. Okay. So I'm going to assume the following of you as the viewer. I'm going to assume that you have coding experience with R. Not that you're an expert, but you can hack, because we will be using, while not necessarily super advanced aspects of R programming, we will be doing some things like we'll be creating our own functions, and we'll be using the apply function, using those functions. that sort of thing. So I will make a certain amount of assumption around your R skill in general. The focus of this tutorial is not R programming, but how you do text analytics with R programming. So I will make some assumptions about your R skills. If you need to brush up on your R skills, we have some YouTube assets and tutorials on our YouTube channel that can help you with that. Okay, you'll need to have some math background. So to be clear, the focus of this particular tutorial series will be most definitely practice and not theory, but we will have some math. That unfortunately, that's inevitable. We will have to have some math coverage of some kind. Otherwise, for example, TF-IDF, we need to explain the mathematics behind it, because that will also explain the benefit that you get for using it. And that's TF-IDF is mighty. You use it all the time in text analytics, so it's important. But we won't drill. You won't see tons of equations. We'll focus on practice. So, and I need to stress this very much. This is an introduction to text analytics. Text analytics, this subject, this domain is very, very broad, very, very deep, super interesting, right? Text analytics, text mining, natural language processing, they all kind of fall under this same banner, the same umbrella. So there's lots and lots to learn, lots and lots of goodness to be had. But this is going to be very much an introduction. In particular, the focus of this series is going to be on the creation of predictive classification models over textual data. So we're going to have a very narrow focus. But this is a very useful thing to be able to do. We'll talk more about this later on in the video series about the various types of scenarios where this is applicable, and there are many. Not only will we be focusing on creating predictive classification models using textual data as the input, we will also be focusing on the 20% of the tools and techniques that you use to build predictive classification models over textual data that can be used in 80% of your projects, right? So we're really trying to do the 80-20 rule here. Introduce you to the 20% that's 80% useful, but note that this is very much an introduction and it is a broad, broad topic, and there's a lot to learn. And lastly, since this is an introduction, we're going to use decision tree ensembles. The predictive models that we were going to build will be ensembles of decision trees, and in particular, we'll use the mighty random forest algorithm. And the reason for that is that it's relatively simple. There are other models that can be used to support vector machines, for example, or boosted decision trees. But we're going to focus mainly on the mighty random forest because it is a relatively simple model, but it is also relatively powerful. Once again, it's an introduction. What we'll teach is broadly useful. You can always do more research on your own at the end of this video series if you're interested in using support vector machines, for example. As I mentioned earlier, there's going to be a GitHub for this video series, and I wanted just to show it to everyone just to make sure they're familiar with it. So here's the URL. This is the same URL that was in the PowerPoint that we just saw. Now, as you can see right now, there's nothing in it. That is because I haven't uploaded the content yet, but by the time you see this video, this will be fleshed out. You will see a nice introductory README, and there will be an R file corresponding to this first video in the series as well. So you can get all of the code that you'll see in this video series from this GitHub. Next up, I also wanted to introduce the data that we'll be using for this particular series. So it's from Kaggle. So Kaggle now has a curated collection of data sets, and here's the URL for the particular data set that we'll be using. This is originally from the University of California, Irvine Machine Learning Repository of Datasets. You can see that here, the UCIML. The reason why we're not using the UCIML datasets directly is because the folks that created this version of the dataset on Kaggle did some data munging for us and created a nice CSV file. So we want to use that because it makes our lives easier. Now, in particular, this is a classic scenario for text analytics with classification models. In particular, this is spam. We're going to have our data set be composed of SMS messages, texts of various kinds, and we have a label to say whether they're ham, they're legit, or spam, they're bad. Okay, ham versus spam. Now, I will warn you that this is raw text data of actual people sending texts back and forth. So there is some stuff in here that is not G-rated. There is profanity. There is some adult material in here. It's nothing too untoward, but just be aware that this is not a rated G data set by any stretch of the imagination. So just wanted to let you know that, because we're working with real world textual data. It's the best kind to get your feet wet, and unfortunately sometimes when you're working with real world textual data, you get a dose of the real world, as it were. Okay. So be forewarned. But here's the data set. Here's the URL. We will be also including a copy of the CSV in the GitHub, because we want to make sure that we have a snapshot of the CSV file available to you in the GitHub for posterity, so that if somebody comes 2 years from now, this file may have been changed, but the code that we have in the repository will work with the copy of the CSV that's in the repository. Okay, so that's the data. Now we know about the GitHub, where you can get the R code that I'm about ready to go through. You know about the data set that we're going to use. So let's just go ahead and get right into it. Okay, so first up, we're going to be using a collection of packages in this tutorial series. At the time of this recording, this being video 1, I believe this is going to be the full set of packages that we're going to use, but I reserve the right to add more packages later. But we'll start with this collection here. And if you're not familiar with R all that much, never hesitate to use the help system. So for example, if I do $!install.packages, I can get the help file. And essentially this is the mechanism by which you can tell R, reach across the internet and please get these packages for me that have good functions that I want to use in my text analytics. And in particular, we're going to be using ggplot2 for some visualizations. We'll be using E1071 via the caret package. Caret depends upon E1071, so we need to have it. We'll be using the quantita package. This will be our main package for actually doing text analytics. It's very, very cool. Has a lot of really good functionality for doing text analytics. We'll be using IRLBA for doing some singular value decomposition, some SVD, some feature extraction, which is really cool. And then lastly, we'll be using the mighty random forest. It's one of my favorite algorithms. It has a lot of power, has a lot of capability. It's very easy to tune. You can get really, really far with random forest if you do good feature engineering, and that's where SVD will come in, as we'll talk about later. Okay, so if I run this line of code, you can see here that R will reach out across the internet, start grabbing these binaries for these packages, and start downloading them, installing them on my machine here. Now, if you already have these packages, or maybe some of them installed on your machine, that's no problem. You can go ahead and use this mechanism, and it'll refresh the packages that you already have installed, which is handy dandy and super nice. Okay, so next up, I've already set my working directory in R to load up the CSV file, but let me just quickly demonstrate that for some folks if they're not used to doing this. So if you go to Session, Set Working Directory, Choose Directory, this is how you tell R where the location of your data files are. This tells R, the RStudio environment, hey, read files from here and write files to here if I so choose. So if I do that, and you'll get a similar experience on Mac, you'll get a Finder window, and you can just navigate using this to the location on disk where you've loaded the spam file, the spam CSV file. Okay. And as always, let's go ahead and take a look at the read.csv function in the help file. I won't drain this. You can take a look at it at your leisure if you're not familiar. But not surprisingly, read.csv says, okay, R, go out to my file system, read in the CSV file, convert it into a data frame, and store it in memory. And in particular, one of the things that we're actually going to tell R to do is, hey, by the way, R, when you read in this CSV file, when you read in string data, when you read in textual data, do not make it a factor. By default, R makes string data into categorical variables, factor variables. And we don't want that because we're doing text analytics. We want the raw text. So we tell R, hey, don't make the strings into categorical variables, into factors. So if we run these 2 lines of code, we get a nice spreadsheet view in R. That's what this view function right here does. Capital V, view, brings up this nice spreadsheet view in R. And we can take a look at the raw data. And a couple things jump out at us right away. First up, these column names aren't particularly useful, and it looks like we've got some funkiness going on here in these 3 columns, because we actually know from the Kaggle website that in fact we only have 2 columns worth of data. We have the SMS text message and we have the label, ham or spam. So this is all extraneous. So let's go ahead and clean that up. So first thing that we're going to do is we're going to say, okay, hey, you know what, R, I don't want all of the columns anymore. I just want the first 2 columns. That's the only ones I care about. So this says, hey, R, go to the spam.raw data frame. Go ahead and filter it. I want all the rows and just give me the first 2 columns. Next up, we can overwrite the labels, because if you remember, they were V1 and V2, and that's not particularly useful. So what we'll do is we'll change the names of the columns, the name of the variables on the data frame, and we'll call the first column the label, right? Ham or spam, it's the label. And next up, we'll just call the second column text. Right? We could call it SMS, we could call it whatever we want. I've just decided to call it text. So if I run that line of code, oh, and as always, never hesitate to use the help system here. Names of an object. Excellent. Excellent. Okay, so this is how you can get the names or reset the names of an object. Okay, and lastly, let's go ahead and run the view code again. And you can see here we now have a nice, well-ordered, well-structured data frame where I've got my label column, ham and spam, and I got my text column. Cool. Okay, so next up, we can see here that we have 5,572 observations. We've got 5572. That's the number of rows that we have in our data frame, in our data table. And we have 2 variables. So one of the first things that we want to know before we start any modeling project, any data science project, is, do we have any missing data? Because missing data is a problem. So the complete cases function, and as always, don't hesitate, use the help system. The complete cases function helps you find complete cases. Return a logical vector indicating which cases are complete. That is, have no missing values. Okay, cool. So we're going to say, hey, R, return me a logical vector. And if I just run this code snippet, I'm going to get a big dump to the output here. Look at that. And we see a lot of trues, which means these are all of these right here, complete. They're not missing any data. But what I'm interested in is not the number of cases that are complete. What I'm actually interested in is knowing the number of cases that are not complete. And that's what I've got the exclamation point, the bang here, the negation operator, not complete. And then if I use the which function, and as always, don't hesitate, which indices are true, right? So if I negate this, things that are missing will now become true. That's the only thing that I care about, and I can ask for the length. And that'll tell me how many of my cases are in fact not complete, missing data. Okay, so I run this line of code, and voila, 0. Excellent. So the data has the data frame has complete data in it. Sweet, that makes our life a lot easier. Cool. All right, so not surprisingly, the first step is always to explore the data. Always explore the data. Now, one of the things that you're going to find often in text analytics, and especially when you're starting to do anything like classification of text documents, whether that's sentiment analysis or spam, you name it, is that you may have to understand what the class distribution of your labels are. Because, for example, in a ham versus spam scenario, it's not uncommon for spam to be actually relatively rare, thank goodness, compared to legitimate textual documents. Or, for example, in sentiment analysis, you would like to believe, especially if you're doing sentiment analysis, maybe about, for example, tweets about your brand, that negative tweets about your brand are actually relatively rare. You would hope that to be true. So that's one of the first things that we want to do is we want to take a look at the distribution of our labels. Now for us, this is pretty simple. We have a binary classification problem here, right? We already know that a SMS text is either ham, legit, or it's spam, bad, not legit. So it's binary. So what we can do is, oh wait, I'm so sorry. I skipped over a line of code here. My bad. First up, my apologies. We need to take our label here and turn it into a factor. Right? We know it's ham and spam. So that's our two categories. So let's go ahead and make that a factor. My apologies. Okay. So now that we've got our label set up as a factor, let's go ahead and run a table on that. And if I just run this line of code here, this will tell me, okay, look, count up how many hams and how many spams I've got. Now, technically, this code would work even if we hadn't made it a factor, but I tend to like to make my things factors early on because it's useful for things like ggplot2 visualizations, as we'll see in just a bit. Okay, so if we run table on our spam.raw label, we can see here the relative count. And you can see here that, while not astronomically small, the number of spam is actually relatively small. But it's usually more intuitive to actually see this as a percentage. And that's where the prop.table function comes in. And as usual, use the help system. Express table entries as fraction of marginal table. That's not particularly intuitive for a lot of folks. So let's just run the code and you can see what happens, right? So here's the dealio. Table just gave me the raw counts. 4,825 hams, 747 spams. What prop.table was is actually to convert that into the percentages. So our data set is 86.6% ham. It's 86.6% legit. And it's unfortunately 13.4% spam. Now this is, while non-trivial class imbalance, it's not bad, right? It's not like 1% spam and 99% ham. But it may be problematic as we move on when we start building our machine learning models. We may want to try out some techniques to account for this imbalance between the two. 13% is not terrible, but we may actually get better performance out of our model if we do some magic to kind of account for this disparity. So that's just something to keep in the back of your mind. But generally speaking, this is a good practice, especially in text analytics and classification in text analytics. Take a look at your distributions of your labels. It's extremely important. Extremely important. Okay. So next up, let's just get a general feel for some more about our data, right? And in particular, let's take a look at the relative lengths of the texts, right? Because if we go back to the spreadsheet view, we can see that some are short and some are longer. So it may be interesting to just take a look at and say, okay, hey, like, look, this one's spam and it starts with winner, right? Okay, cool. It's a longer one. Maybe there's a propensity for legit texts to be shorter and illegitimate or spam texts to be longer. It's entirely possible. So the easiest way to do that is just to create a new feature on our data frame. I'm just going to call it text length. And we can use the nchar function and nchar. Count the number of characters. Excellent. So go through every SMS text in our data frame one by one and calculate the length in characters and store that for me in a new feature, a new column on our data frame called text length. And then lastly, hey, do a summary, and not surprisingly, object summaries, not particularly useful, but when you see the output of the code, you'll know what it does. Do a summary on text length. And there you have it. We have some summary statistics on the length of texts. And by the way, if we go back up here, you can see now we have a new column added to our data frame called text length. And you can go down here and you can see, there's some variance going on in text, right? 28, 27, 19, 142, 172, 291. And you see that there's a lot of variance in this data. So this could be potentially interesting. So if we look at this, we can see here, well, we've got quite an interesting distribution. I mean, look at this. At the max, we got 910 characters. That's quite a long text message. But we also have a minimum of 2 characters. And probably even more interesting is that our median, the median value, the 50th percentile, the value at which half the texts are shorter than this and the value at which half the texts are longer than this is 61 characters. So that's a pretty big disparity here. Pretty big disparity. And you'll also notice that the mean is, 19 characters? Fully 19 characters higher than the median, which means that there's probably a certain amount of skew here, which is indicative right here of the third quartile. So 75% of the text messages are 121 characters or less, and only 25% are 122 or more. So there may be some skew here to account for these two differences. So let's take a look at the distribution using a histogram using the mighty ggplot2. That's what we'll do next. So we're going to go ahead and load up ggplot2. Oh, and look at that. Stack Overflow is a great place to get help on ggplot2. Absolutely. Okay, so here's ggplot2. Now what we're going to do is we're going to plot a histogram. We're going to visualize this distribution using a histogram, and we're going to segment it. We're actually going to also use the power of ggplot and say, look, you know what? Color code the bars in the histogram. Color code the bars with the label. So that'll give me some sort of graphical understanding of the relative proportion of ham versus spam in the context of text lengths, the lengths of the texts. Right? And this is super useful. The reason why we had to make label a factor earlier was because if it wasn't, this fill wouldn't work and we wouldn't get the awesomeness that we're about ready to see. And you'll notice here I've arbitrarily picked a bin width of 5. And I did that mainly because just taking, just eyeballing this data, 10 seemed like it was probably a little too big of a bin width and 1 was probably way too small, so I just used 5. Okay, so let's go ahead and run this line of code. And here we go. We get this nice handy dandy plot where, as you can see here, the turquoise color is the spam and the orange color is the ham. And notice it's super interesting, right? We had an hypothesis earlier that said, look, you know what? It just eyeballing the data, just pure wild speculation by eyeballing the data. We had an intuition that in general, spam would tend to be probably longer text, and shorter text would probably tend to be ham. And we see that actually quite clearly. Now, as we move on later in the series, we start talking about feature engineering, we may actually end up creating a few features that aren't actually based on the raw text itself of what was actually typed into the SMS text message, but we will derive some features potentially that may be useful, like this one. This one may actually prove to be quite useful, actually, from a classification perspective, right? And you look at this, I mean, the texts in basically, well, probably all the way up to about maybe here, this range, are overwhelmingly not spam. So this may be a pretty good predictive feature for us, potentially. So this is super useful. Super useful. Now notice, though, that check it out, though. The extremely long lengths of text, though, are actually, the vast majority of them are, in fact, ham. They're not spam. So there's this kind of sweet spot, right? So maybe this, working in conjunction with some textual-based features that we'll engineer later on, may actually be pretty powerful in determining ham from spam. Okay, so we're going to try and keep these videos around a half hour or so So I'm going to go ahead and end the video, this video right now at this point. All of this code through this wonderful ggplot2 visualization will be up on the GitHub by the time you watch this video. Thank you for watching. Like I said earlier, if you like what we're doing here, please subscribe to the Data Science Dojo YouTube channel. Also, if you like what we're doing here in general, go ahead and connect with us on social media. And lastly, I hope to see you in one of our upcoming data science boot camps. So until next time, I wish you very happy data sleuthing.